Have you ever noticed that when air is expelled out of a balloon, it moves upward? Why do you think it happens? It happens because the balloon exerts the force on the air, which acts downwards. In response, the air exerts the force of the same magnitude on balloon, which acts upwards. Here, two types of forces are being discussed. The action force, the force exerted on the second body by the first body, is the action force. In this case, action force is the balloon exerting force on the air. And the reaction force. Reaction force is the force exerted by the second body as a response on the first body. In this case, air exerting force on balloon is the reaction force. Here an interesting concept is that action and the reaction forces are of the same magnitude but are in opposite directions. This example comes under the Newton's third law of motion, which very simply states that every action has an equal but opposite reaction. Let's take another example. During a football match, when Ronaldo kicks the football, he exerts an action force on the ball. Do you think the ball will exert a reaction force in response? Of course it will. The ball will exert an equal but opposite reaction force on Ronaldo. But why doesn't Ronaldo accelerate much? You would know this if you remember Newton's second law of motion, which says that acceleration is inversely proportional to the mass. Here, mass of Ronaldo is much greater than that of football, that's why he doesn't accelerate much. You might question this law in such a way that if the action and reaction forces are equal in magnitude and opposite in directions, then they should cancel each other out without any motion. But it's not the case. It is just a misconception of Newton's third law. Here, the action and reaction forces act on different objects rather than only one object of the same system. An object does not move if two equal forces act on it in opposite directions. Let's clear this misconception by taking the same balloon air example, where the balloon exerts an action force on the air downwards, which is the only downward force acting on the air in the system. In response, the air exerts a reaction force on the balloon in an upward direction, which is the only force acting on the balloon in the system. Therefore, action and reaction forces do not act on the same body. They act on different bodies of the same system. That is how objects experience motion. Applications of Newton's third law of motion. Do you really feel like that there is rocket science behind the working of Elon Musk's or any type of rocket? Not really. You'll get surprised if I tell you that rockets work on the basis of third law of motion. In a rocket, burning fuel creates a push on the air, which in turn exerts an equal and opposite reaction on the rocket, moving it in an upward direction. This is how a rocket enters the space. Quiz. Do action and reaction forces act simultaneously or in succession? The answer to this question is in the description box below. Test yourself sincerely. Smart End. You can remember this whole concept easily by renaming this law as action-reaction force for your ease, in which two equal forces are in opposite directions and they are acting on different objects simultaneously. Here you have to remember some simple terms that are action, reaction, equal and opposite forces acting on different objects simultaneously. And this is how the objects in the universe experience motion. Thank you so much for watching this video. Subscribe for more such videos. Smartitute. Learn fast, adapt well.